Alright, in this video we're going to talk a little bit about acids and bases. So if you remember from previous videos about solutions, we've learned that a solution is simply when you have one substance dissolved in another. Typically this is, in a classical sense, it's something that is a solid powder type substance that we dissolve in water. A great example of a solution is a Kool-Aid, drinking Kool-Aid from a powdered mix. You take your powdered sugar solution like grape Kool-Aid, you add some water to it, and then you get a Kool-Aid solution that you drink, and it's all uniform. Acids and bases basically function like a special category of solutions for us to think about. So when you think of acids and bases, keep in mind a lot of the same things that we've learned about solutions while we're talking about them. And one of the first things that we like to talk about with acids and bases is that there's a whole bunch of definitions that we can use to define whether or not something is an acid or if it's a base. And one of those first definitions that typically gets talked about in chemistry is called the Arrhenius definition of acids and bases. So in this Arrhenius definition, you'll see a whole bunch of these definitions, but an acid is defined as something that, make my eye a little better here. An acid is defined by something that produces H plus ions when it is dissolved in water or when it is in a solution. And kind of on a similar idea, a base is something that produces an OH minus. Right, so how are these things going to produce these H pluses and OH minus? Well, it's about the dissociation that happens when an acid or a base is in water. So let's look at some examples of this. So draw a little line here just to separate. So if you have an acid, a common acid is hydrochloric acid, which is HCl. And if it's a solution of hydrochloric acid, it will dissociate into ions. And those two ions, right, hydrogen and Cl are the two elements here, hydrogen and chlorine. So it'll break apart into its two ions, which are an H plus ion and a Cl minus ion. And the truth is that it's really the H plus part of the HCl that is the acid, right? If you think about what hydrogen is one proton and one electron. So if you have H plus, now it doesn't have that one electron, so H plus is really just one proton, which chemically has a lot of power. And that's kind of why acids have their own category. With a similar idea, so this is an acid up here. HCl is an acid. In kind of a similar idea, we have, let's switch colors, the base, right? So the base we can see something similar with, or bases we can see something similar with. We just said a second ago that when bases are in solution, they will produce OH minus. So a common example of this is sodium hydroxide, which is a strong base. It's a pretty classical example here. So NaOH is your example of sodium hydroxide that is a base. When NaOH is in solution, so let's put an AQ next door, it will dissociate into its two ions just like the HCl did. So it'll form, let's see, we've got a sodium ion and we've got OH is a polyatomic ion called hydroxide. So this will separate into two ions, Na plus and OH minus, right? And kind of like how the H plus is the important part of the acid, the OH minus is the important part of the base. So this is a summary of the Arrhenius definition of acids and bases. It's a pretty straightforward definition, right? Your acids are producing H plus ions, and your bases are producing OH minus ions.